Welcome to Stream of Conscience, brought to you by Democracy for America, Fairfield County, where we believe that change is possible and you can make it happen. I'm your host, John Hartwell. Our guest today is Mark Robbins, a real estate consultant with expertise in energy conservation, habitat management, and sustainable construction. Mark was responsible for Windermere on the lake, an 80-acre conservation development featuring one of New England's first LEED certified homes. He's taught at Columbia University on the subject of sustainable development, is a board member of SoundWaters in Stamford and the new Canaan Nature Center, and he also serves on the new Canaan Conservation Commission. Mark, welcome to Stream of Conscience.
Well, good morning. Thanks for having me, John.
So, Mark, you were responsible for the early development of the Windermere Lake project in North Stamford, and you came at this with the idea of doing sustainable development and working with the land and using state-of-the-art techniques to save energy and to make the homes really something special. Can you talk a little bit about that?
Sure, I'd love to. Well, it was an exciting opportunity sort of to develop the first uber green planned community at a very high end here in Fairfield County, Connecticut. And it was actually featured on CNN during Earth Day. Our first home was the first LEED certified home in the Northeast.
And what is LEED certification?
Well, that is the Leadership in Energy and Environmental Design program sponsored by the U.S. Green Building Council.
Okay.
And it's a point-based system to try to promote green building, sustainable design techniques where you reduce waste, increase energy efficiency, increase air quality, daylighting, and make projects more durable and healthier to live in.
Okay. And how difficult was that to achieve in in an economically sustainable way? Because people are building large homes all over Fairfield County these days, McMansions, and some of them are all beautiful, but I don't know that they're necessarily energy efficient.
Right, well, that's a good point. It was a lot to do all at once. So you have to look at the operating cost and the net present value of the investments to come up with the economic return.
Right.
We ended up really focusing...
That's MBA speak for making money.
Making money, right. So certainly there is a fear of change in the construction market, and the subcontractors and trades want to charge you more for anything that's different than what they've done before. But we started with a thermal envelope and trying to create a very efficient and controllable space.
Thermal envelope.
Right, so it's like building a thermos. You want to create the best moisture barriers and the best energy barriers so that you could trap the heat or the coolness you've created within the home to try to conserve it.
Okay. And then beyond that, what do you do?
Well, then we looked at design techniques to maximize or minimize solar gain, energy modeling.
Solar gain.
Right, okay. So we want to be facing into or away from the sun, depending on what rooms are planned for what space. We want to design a roof that reflects the heat of the sun if we're in a climate that's exposed to a lot of heat and we've got challenges with cooling. We want to design in a way that the construction minimizes energy loss. And we want to create ultimately an enjoyable and healthy living environment inside.
So, stepping back, how much extra cost would be in a project like that if from the very beginning you said, I want to do this responsibly, I want to do this with energy conservation as a main focus here, I don't want to give up making it beautiful and attractive and livable and all of that, but I also want to add these other things on. Does that add significantly to the cost of the project?
I think it still does, just because it's a new and better way of building, to some degree more thoughtful, and it employs more consultants or more construction oversight, roughly speaking 10 to 15% more, not factoring in the additional time to get the inspections for new technologies.
But then I'm assuming that you can also recoup some of that thing, that some of that cost. If you're not using as much energy, for example, down the road to heat your home during the winter or to cool it in the summer, there must be savings there. And does that, over a 10 or 15 year period, would that offset that initial cost of the construction.
Well, it certainly does. In fact, one of the statistics we like to share is that the 8,000 square foot home we were building had a lower energy cost to operate than the 800 square foot trailer we were operating in.
Well, but the trailer, to be fair, has probably not been engineered to be environmentally sustainable.
Well, that's right. Yeah, pretty thin walls. So.
Yeah, right. So inside the house, I mean, you've got this envelope where you're obviously trying to contain the cooling or the heating and not have loss. So inside the house itself, there were some other techniques that you used as well.
Sure. So we employed a lot of LED lights, which
Okay.
are more expensive up front,
Yep.
but they burn cool and they last long.
Right?
We used low VOC flooring materials
VOC?
and volatile organics.
Okay, sorry that I asked.
So, right. So where possible, we're buying finishes and materials that don't have a lot of ammonia, for example.
Oh, okay.
That are water-based solvents or finishes. So that reduce the off-gassing, so we have an opportunity to create fresher air inside.
Off-gassing. Tell me about that. What is that?
Okay, so the chemicals that are impregnated in paints, floor finishes, polyurethanes often have a negative impact on environmental health over time.
So if you're doing a home project, and let's say you're going to reconstruct your kitchen, right? You're going to blow it out and put something else in. If you go to Home Depot or Lowe's and buy their sort of standard hardware cabinetry stuff, what is it likely to be, you know, what's the problem with that in terms of off-gassing, which is a term I've never heard before?
Well, often for durability benefits, woods and materials are soaked in chemicals that keep them from warping or discoloring over time.
Right.
So that's something to be aware of. Overall environmental footprint, you might want to think about where materials are sourced from and that they're developed and produced in a more sustainable way. So you defer to materials like bamboo as a flooring surface over oak, just because it grows quicker and it's easier to reproduce.
Is it also healthier for you in the home?
Right, so you don't, it's resistant to mold, for example. But overall, within that thermal envelope, so we were looking at energy control. So with a really tight thermal envelope, we're able to prove the efficiency of the equipment inside. We're able to mechanically port and create more fresh air when needed through things like energy recovery ventilators, or HRVs.
Energy recovery ventilators. How does that work?
So what it does is you could simply open a window to port fresh air into your kitchen.
Yes.
But you'd lose the heat.
Yes.
So an energy recovery ventilator allows you to bring in fresh air or exchange it, but try to equalize the heat. So the hot air would pass through a system in the HRV, basically a series of straws, and heat up those straws so that when the fresh air comes back in on the outside of the straw, it retains and transfers the heat again. So you reduce the energy loss.
Okay.
But all these things are code in Canada, but there's sort of new concepts here in the States.
That's really interesting, and we should come back to why that's the case. One of the other things that I think you did was thermal wells.
Geothermal.
Geothermal, right. So talk about that.
Right, and geothermal is a pretty low-tech system. At the end of the day, you're trading oil or propane fuel costs for heating, principally, against electric costs. So you need to balance that equation.
So exactly what is a geothermal installation?
So 5 feet below the frost line, just like when you go into your basement in the summer and it's cool, and it's probably a little warmer than the outside when you go into your basement in the winter if it's snowing outside, you've got a stabilized temperature of about 55 degrees below the frost line.
Right.
So you're capturing that and you're using it to either heat or cool. And you're getting that temperature, you're accessing it by using wells that could be shallow wells wrapped around the house 5 feet down, or they could go down several hundred feet directly. And you're using a cased well typically, and the material that you're using to exchange the heat instead of water, which typically calcifies, is something called R410A. It's a biodegradable refrigerant, which is a pretty good conductor. And you can pressurize it to heat it up, or you can let it expand to cool. So that's the concept behind a geothermal heat pump.
So if I got this, well below the house, there's a temperature that is fairly stable in the ground. and you circulate this liquid, which is somewhat like water, but it's not water. And it takes on the temperature that's down below and then brings it up, and that either helps you heat or cool the house.
That's right.
Yeah?
Right.
And what's the cost savings of doing something like that? And how does that work economically?
Well, so in theory, you can generate a warm environment. You can heat your air by using this geothermal heat pump and then slightly pressurizing that material to heat it up instead of oil or propane to heat your house.
Okay.
But you are using electricity to run the pumps and to blow the air across the equipment.
So there's no free lunch?
So there's no free lunch, right?
Okay.
And you reverse that process to cool the house.
I remember in your materials where you talked about having overhangs from the roof to protect windows so that in the summer, when the sun is high and very strong, the sun's shine is not coming directly into the house.
Right.
But that in the winter, when the sun is low and not as strong, you do get the sun coming in and you capture that heat.
Right.
And that actually reminded me of living in Iran years ago. And in Tehran, all of the apartment buildings are built so that the southern exposure of the building, whether it's on the north side of the street or the south side of the street, the apartment has this huge southern exposure. And it was exactly the same thing. They used floor-to-ceiling glass on these apartment buildings, and everybody would have a little terrace that faced south. And I said, why are you doing this? It's so hot in the summer. They said, yeah, but in the summer the sun is up there and it doesn't come in. But in the winter, the sun is lower and we get to capture all of that heat. And so this was an example of passive heating, which worked very, very well.
Right, exactly. And that brings us to modern concepts like active facades, where you have this brise-soleil concept, or the brim of a hat that shadows the window.
Okay.
And then they can be motorized so that they could change with the angle of the sun.
Okay.
But that's part of the architecture, is extending the eave lines, extending the overhang of the roof to provide some passive shading.
And that seems very simple.
It is, yes.
So the houses themselves were constructed to be very energy efficient. And I'm assuming the rest of the development went along with that. But as we just said a moment ago, there's no free lunch. You have to have power coming in from some source. And the power generation in this country is a huge issue. Our electricity costs here in Connecticut are the highest in the country. And I don't think do a whole lot of power generation here. We buy it from somewhere else. It was when we deregulated the power industry a few years ago, it was supposed to save us a lot of money. It hasn't. So why is that, and what should we be doing?
Well, there's a lot of things we could do, starting from the inside out, that become municipal concerns and state concerns. What's very exciting right now is the opportunity for locally generated power through distributed generation. So if you're proximate to a gas line, for example, two of the problems we've got with the grid right now is that there's inherently a lot of loss in the lines as power is distributed over miles.
Right. If you're generating the electricity 100 miles away in some sort of power plant and you're shipping it down here, you lose power over the line as it comes down here. So they start off with 100% there, you get much less of it here.
Right, exactly.
So we have to buy it all.
We have to buy it all.
Right.
We have to buy it all. And there's the opportunity for risk of power failure all along those lines.
Yes, which we never have here. We're so fortunate
Right.
in Fairfield County. We never have power loss.
Right, exactly. So it's a hot issue, certainly. People are energized about it.
Okay.
So combined with the fact that we have among the highest electricity costs of the country right now here in Fairfield County, paying almost 18 cents a kilowatt hour,
Wow.
and the least reliable service, there's certainly an opportunity for change.
You think so?
I think so.
Okay.
So we can harden the grid, we can repair the power network that we've got now, and by doing a few things, using Hendrix cable or tree wire that's a little more robust and less likely to snap when a limb falls on it.
Okay.
And we could start to employ patches to the grid or smart grid technology using devices called reclosers, which are basically electronic two-way switches that sense when there's been a power failure or a termination in the line, they can redirect power power to another location.
Okay.
So that's sort of the patch concept.
Yeah.
But how do we get to generating power cleanly, locally, in a more efficient way? And that has to do with the opportunity for distributed generation.
Okay.
Where if we can tap a gas line, we could use, for example, a fuel cell. And Connecticut's one of the biggest producers in the country of fuel cells.
Right.
And it's basically a big battery, no moving parts. It's an electrochemical reaction that uses natural gas to generate electricity.
So when you say tap a gas line, there are, in fact, natural gas lines that cross the state that are delivering natural gas from one point to another. And you're saying we should be able to tap into these. And actually, we would then obviously be buying some of that natural gas in order to run these fuel cells.
Right.
So where is that a possibility today?
Well, part of the governor's new strategic energy plan here is requiring the expansion of the gas lines by approximately 900 miles. In the town I live in now, in New Canaan, we have an easement for the Tennessee Valley gas line, currently a Yankee gas line that runs through Waveney Park, but there is no access to natural gas, so we would have to tap it using a pressure gate to reduce the pressure and make it accessible for local distribution.
And then what could you do with that?
Well, you've got two things. Natural gas is very exciting because it allows us to convert from oil heat as a form of heat, converting from oil to natural gas, which has the benefits of reducing our exposure on foreign security issues, a less expensive form of heat, and it burns clean. So there's a lower carbon footprint and it's more reliable simply because it's cleaner.
Right.
Less maintenance required to maintain the equipment. But that's just converting from oil to natural gas for heat. What's really exciting is when you have that connection, you can generate electricity using either a cogen turbine or a hydrogen fuel cell and generate power locally with compact systems that create a more reliable and cleaner source of energy and ultimately less expensive.
So why isn't this being done today?
Well, it's starting to happen. It's starting to happen. We're starting to see microgrids adopted. About 20 communities in Massachusetts have adopted this concept. There are a couple here in the state right now, but it's a confluence of opportunities, really. The fact that the equipment has become more compact and more reliable to generate power, and the disparity between the current electric costs, what we're buying it off the grid, and what we can create it locally.
But you would think CLNP would be all over this. I mean, I don't believe, and maybe I'm wrong, but I don't believe they have an inherent desire to keep the prices high because they're paying for this at the other end, and it is still somewhat of a regulated industry. So why aren't they in the forefront of developing this, locally generated option?
Well, it's a complicated question. Early on, one might think they weren't incentivized to reduce the electricity consumption, but now that the mothership that owns CLNP, Northeast Utilities, also owns the gas lines, they'll be making up the difference.
Okay. So they'll be selling it to us one way or the other.
That's right.
So why not sell it to us in a way that's more environmentally sustainable and less expensive for everyone?
Right. Well, I think that's going to start to happen, and that they're cooperating with the governor's strategic energy plan. A few policy changes need to be made and are starting to happen. One is the ability to sell the power that's the excess power back to the grid at retail rates, so that if Westport, for example, were to take on their own power generation, they could help their neighboring communities by reducing the load by feeding power back to the grid.
In some places, in some states, it's actually possible for the individual consumer to feed power back into the grid and get paid for it. If you had on your land, for example, some sort of water turbine that you could run off of a stream, you could generate electricity and put it back into the grid and get paid for it. But I'm not sure that that's the case here in Connecticut.
Residentially it is,
okay.
But it depends on the scale. And the programs and the equipment vary, whether it's solar or fuel cell generated power. effectively, they're not looking for you to generate more power than your typical base load to make money off of it. But in the event you're generating power through solar capture, for example, and you're not home, your meter can reverse.
So talking about solar for just a moment, and we've had programs to put in solar panels. My understanding is that they're still fairly expensive and that the economic return on them is not high enough unless you have some sort of subsidy coming from the government. Is that the case?
Yes and no. I mean, there is a definite return, and that return looks more and more attractive as we lose power. So regardless of the cost of the power, many people in Fairfield County were out of power for a week recently.
Yes.
If they had solar power, they were generating power on their own.
Yes.
So regardless of the cost of the investment, there's an immediate benefit.
Well, but they could have had that by having a generator as well, and a standby generator and feeding that off of a gas line.
Sure, sure. And there's a cost to that, installing the generator and buying the propane. There's no free lunch.
Right.
But there are several programs. The panels, people that looked at panels and dismissed the concept a few years ago should look again, because the efficiency of the panels, just like computer chips, have been doubling about every other year.
Okay.
And the cost of the equipment has been going down dramatically.
Okay.
And coupling that with federal tax rebates and local incentives through programs like ZRECs or reverse auctions, where the installer actually gets a credit for participating in clean energy, there's a way to start to package it and make the returns more attractive.
Okay. So if someone is watching today and they're thinking, you know, I like these ideas, but I don't know why they aren't happening today. What can I do to help make this go forward? What would you suggest? How can people get involved?
How can people get involved? Well, on the technology piece, the thermal envelope and insulation is the #1 thing to do. Okay. That's sort of the low-hanging fruit. However you produce your power, making sure it's controllable and you're not losing it, is the first investment.
Right.
The next thing, after looking into an energy audit and contemplating converting from oil to natural gas, introducing solar, or where applicable, wind, is to look towards your municipality for guidance. And I think the local governments can start to inform conservation and energy commissions so that they're promoting sustainable building practices through incentives, right? So knowing that you get less of what you tax and more of what you incentivize.
Are planning and zoning regulations, do they play a part in this?
Unfortunately, at the residential scale, not very much. They help with code compliance, but they're not doing a whole lot to promote green building. In other words, they're not giving accelerated approvals necessarily, or helping to shepherd a real estate project and expedite it through the entitlements if it meets certain energy benchmarks.
Who sets the codes?
Well, they're done locally.
In the town or at the state level?
Well, what I'm talking about are programs that local planning and zoning or economic development groups could adopt to promote more sustainable and energy efficient development.
Is there anything that can be done in Hartford to set statewide codes that would encourage people to take more action on their own?
Yes, there is, and I think that's starting to happen through the joint task force created under Dan Esty, Department of Energy and Environmental Protection, where he synthesized the Department of Energy with the Department of Environmental Protection to create continuity there. So one of the programs that they're underwriting now is something called CPACE, which is Commercial Property Assessed Clean Energy. And there'll be a corresponding program, hopefully, for residential, which would be RPACE.
Okay. So at some level, we're dependent upon the government to be the regulator, to set the standards and make sure that they're followed, and to provide leadership. What other sort of citizen organizations are there that people could look to say, these guys are pushing for the right thing, I want to help them?
Right. Well, it depends on the town. The bigger cities tend to have a robust, or starting to adopt robust sustainability plans and often have a director. But the smaller the communities, the smaller towns, may rely on citizens to get together and organize a task force, for example, an energy task force. And it depends on the opportunities and the needs of each town. An energy task force might be focused on simply hardening the grid and promoting better power delivery systems, or they may want to get together to be the repository and the organization that would seek grants for solarizing their community, for example.
Well, there certainly is a lot going on, and given the state of the grid at the moment in Connecticut, when we have a storm, and we've had some pretty big storms, I don't want to sell them short, but still, to have all those trees come down on all those wires and have to bring in people from hundreds or thousands of miles away to fix things doesn't seem like a sustainable way to approach the future here. So I'm hopeful that we can start implementing some of these things and reduce the stress that people feel, because, you know, I mean, there's still people here today, we're more than a week out from the storms, who don't have power, and it's unacceptable.
Right, that needs to change. And luckily, we've got the technology to do it. Connecticut's the home of innovation. We invented the typewriter and the Jarvik Heart and the radar and the Lego and the Frisbee. And the cotton gin. And we're producing fuel cells, so now we just need to adopt them locally.
Well, Mark, thanks very much for coming in today. It's been a real environmental eye-opening session. I love it. Thank you.
Thank you. Appreciate it.
That's our show for this week. We hope you enjoyed it. You can catch all our shows on YouTube by going to youtube.com/user/DFATVnet. We're also on Facebook and Twitter, and you can send comments or suggestions for a show to info@dfa-tv.net. If you'd like to learn more about progressive political action, we meet on the first Wednesday of the month at 7 p.m. at the Silver Star Diner in Norwalk. We'd love to have you join us. Remember, change is possible, and you can make it happen. This has been Stream of Conscience. I'm your host, John Hartwell. Thanks for watching.